We want to find the product of the monomials. In the first example, we have 8x to the 10th times 4x to the 5th times 6x squared. To find the product, we multiply the coefficients and we multiply the variables. But if it's helpful, we could change the order of the multiplication using the commutative property of multiplication. 8x to the 10th means 8 times x to the 10th, 4x to the 5th means 4 times x to the 5th, and 6x squared means 6 times x squared. Changing the order of the multiplication, we could rewrite this as 8 times 4 times 6 times x to the 10th times x to the 5th times x squared. And now multiplying, 8 times 4 is 32, 32 times 6 is 192. And now multiplying the x's, we have x to the 10th times x to the 5th times x squared. Notice how we have a total of 17 factors of x. We're using our exponent properties. When multiplying and the bases are the same, we add the exponents. So this will give us x raised to the power of 10 plus 5 plus 2, giving us a final product of 192 x to the 17th. For the second example, we have 2xy to the third times negative 3x squared y to the third times 4x to the fourth y. It's important to recognize here the exponent on the x here is 1, and the exponent on this y here is also 1. And now multiplying the coefficients, we have 2 times negative 3 times 4. Multiplying the x's, we have x to the first times x to the second times x to the fourth. And multiplying the y's, we have y to the third times y to the third times y to the first. So multiplying, 2 times negative 3 is negative 6. Negative 6 times 4 is negative 24. And then x to the first times x to the second times x to the fourth is x raised to the power of 1 plus 2 plus 4. And then y to the third times y to the third times y to the first is equal to y raised to the power of 3 plus 1, which gives us a final product of negative 24 x to the power of 7, y raised to the power of 7. I hope you found this helpful.